Completing the square. This is a nifty little trick that we use to solve problems, quadratics specifically, that do not factor. So first, how do we complete the square? What are we trying to do? When I say complete the square, what we're trying to do is come up with what number gets added to the end in this blank. What number do we have to add so that we make it factor into x plus something squared? Well, the process to do that, it's a couple steps, but no step is really complex or difficult. They're very simple steps, so you just have to learn the step process to make it into something squared. So here's the process. First, we have to divide everything by a. A is that number out front. We say it's ax squared plus bx plus c. So a, that front number, we're going to divide everything by 2. And we're not really solving, we're not really simplifying, we're just showing a process here. So normally we'd want to do the same thing to both sides or factor out the 2, but we need to get rid of that a. Divide by a, leaving us with x squared plus 20 divided by 2 is 10x plus our blank. That's step 1. Divide everything by a. Step 2 is to find what I'm going to call the magic number, the number that makes it a perfect square. And how we do that is we take the middle term, often called b, the middle term, b, which is now the 10. We're going to take that 10, we're going to divide it by 2, and then we're going to square it. So 10 divided by 2 is 5 squared, which is 25. So take that middle term, the 10, divide by 2, and square it. That is the magic number that we need to add to our expression. That's what goes in the blank. X squared plus 10x plus 25. And if it was an equation, we would want to make sure we did it to both sides of the equation. But add that magic number to the equation or the expression, and now it's something that we can factor into something squared. And what's nice is it's really simple. The square root of x is x. We take the sign from the middle, which is plus, and we take the square root of the last term, which is 5, and now we factored it. So the two big things, what we wanted to add to make it a perfect square, the magic number this time was 25, so that we could make it into factored something squared. That's the process of completing the square, and we use this process in a lot of different contexts. Today, we're going to try and answer the question of why do we need to complete the square? Well, lots of reasons, but today we are going to complete the square to solve quadratic functions. Functions like negative 3x squared plus 24x plus 60 equals 0. Let's say I tried to factor this. It wasn't easy. Maybe it's impossible. And so instead of factoring, we are going to complete the square to solve it. And this is a nifty little trick. First step, we need to get rid of this constant term. It's in the way. So we'll subtract the 60 from both sides so that we only have variables on the left. Negative 3x squared plus 24x equals negative 60. Next, once the variables are on one side and the constants on the other, we need to get the a out of the way. And just like we did before, we're going to divide by a, that number out front, divide by the negative 3. And now that it's an equation, we can do it to both sides. Do the same thing to both sides of the equation. When we do, the negative 3's are gone, leaving us with x squared minus 24 divided by 3 is 8x equals negative 60 divided by negative 3 is 20. Divide everything by a. Next step, find that magic number. Remember, b divided by 2 and square it. It's always the middle term divided by 2 squared. 8 divided by 2 squared. 8 divided by 2 is 4. Squared is 16. 16 is the magic number. It's magic because it's going to make a perfect square for us when we add it to both sides of the equation. We're going to add 16 on the left, and we're going to add 16 on the right. This gives us x squared minus 8x plus 16 equals 36. And once we've added it to both sides, we should be able to factor into something squared. And sure enough, this one does factor. We take the square root, the sign from the middle, and the square root from the end. So this is x minus 4 squared equals 36. This is nice because we can solve this really quickly by taking the square root. A little step here, though, when we take the square root, we need to have a plus and a minus. We're going to actually end up with two answers because 6 squared equals 36, but also negative 6 squared equals 36 because a negative times a negative is a positive. So we don't know which one it is, the positive or the negative, and so we're going to account for both when we take the square root of both sides. So this gives us our two equations. X minus 4 equals 6, or x minus 4 equals negative 6. We're not sure which. From here we can solve really quick by adding 4, and our first answer is x equals 10. Or if we add 4 to the second equation, our next answer is negative 2. So if we can take the square root of both sides, we'll have two equations, the positive and the negative. This process to solve by completing the square is very simple. It's just a matter of learning the 5-step process to get it set up in the form we want. So let's take a look at another example. Here we have 4x squared minus 7x plus 1, and this time it does not factor. As hard as you try, you'll never be able to factor it. So, step 1 was to get rid of that constant term. We're going to subtract 1 from both sides. That gives us 4x squared minus 7x equals negative 1. Step 2 was to get rid of the a term. We get rid of the a term by dividing both sides, everything, by that 4. And when we do, we get x squared minus 7/4 x equals negative 1/4. Now we find the magic number that we can add to both sides. Right now, the middle term is negative 7/4. We need to divide by 2 and square it. But whenever I have a fraction, instead of dividing by 2, I'm going to multiply by 1/2. Same thing as dividing by 2, multiplying by 1/2 and then squaring it. Because now I can multiply straight across and we get negative 7/8. And when I square it, 7 squared is 49 and 8 squared is 64. The magic number quite often is a weird and inconvenient fraction. But that's okay. We're going to add that to both sides. 49 over 64. Add 49 over 64. So on the left, it's just x squared minus 7/4 x plus 49 over 64 equals, on the right, we need to get a common denominator. Common denominator here is 64, so we're going to multiply both parts by 16. And that's going to give us negative 16 plus 49 all over the 64. And that's going to be 33 over 64. Now we can factor, and it factors, even though they're ugly fractions, it factors really easy. Square root of x squared is x, sign from the middle, and then the square root of the fraction, square root of 49 is 7, square root of 64 is 8, equals 33 over 64. We have completed the square. Once we have a square, all we have to do to solve is take the square root of both sides, and square root are inverses, leaving just x minus 7/8 on one side, equals. We can't take the square root of 33 really nice. So when it doesn't come out nice, instead of setting up two equations, we're going to cheat for just the ugly ones. We're going to say plus or minus the square root of 33 over, we can take the square root of 64, that's 8. So to solve, we add 7/8 to both sides. And for our final answer, x is equal to, we already have the common denominator of 8. Unfortunately, that's the best we can do. So we've got a 7 and a plus or minus square root of 33. Because of that square root, our answer looks really ugly, but it actually is the answer. We can plug it into our calculator and figure out what decimal is kind of close to the square root of 33 to get a better idea. Or we can just leave it like this, 7 plus or minus the square root of 33 divided by 8. So that's the process of completing the square. It feels scary at first because it's new, it's very different, but each step is very simple. So if you focus on learning that 5-step process of getting rid of the constant, dividing by a, find the magic number, add it to both sides, and then factor to a perfect square, these problems solve quite nicely. And now you can solve anything, whether it factors or not.